Whoa, it's loud. Okay, so think about it in your head. Best ways to learn programming. All right, so think for your head for a bit. So is it from books? Is it from MOOCs? Is it from classes and such? Really, there's not much of a substitute for having someone there face-to-face with you, helping you debug. Right, so if you have, in this case, in a classroom, you have two students, they're sitting next to each other, they're helping each other pair program, debug, explain how execution works. Barring that, you may have say a computer lab where you have one TA or instructor walking around a lab with maybe a dozen or 2 dozen students and helping them as well, right? So they can the instructor can kind of look around, see who needs help, maybe someone's raising their hand and stuff. So I did some formative observations in the computer lab in our university. And the overriding thing that I noticed was that tutors were really feeling overstretched. So the ideal for this sort of tutoring scenario in an in-person setting is timely, targeted, and proactive help. So timely means that as soon as a student gets stuck on something, they can raise their hand or the instructor can notice and jump in right away, so it's fresh on their minds. Targeted means that it's not an automated technique. They're not getting some kind of canned solution or anything. You have a human actually there providing customized help. And proactive is also really important because a lot of times, especially novices, some of them might be shy. They might not want to ask for help, or they might actually just be stuck in an infinite loop in their head. Right? They're debugging something and they don't actually know how to step away. So a good tutor will be able to monitor the class and see who actually needs help and jump in politely and say, oh, it looks like you've been stuck in this for a while. Do you need help? So that's the ideal. But as anyone who has worked in a computer lab knows, the reality is a best effort scramble. So you have one instructor here, usually optimistically 20 learners, 20 students in classroom. Maybe some labs have 30 or 40 for one TA in office hours. It's physically just an exhausting scramble. So TAs reported after their lab hours done, they're just physically exhausted because they have to run around frantically helping everybody. So this situation seems like a challenge in an in-person lab, and we'd want to build tools to help with that. But if we think more broadly about online settings, it even gets worse, right? So there are far more learners, an order of magnitude or two more learners, and there are way fewer or even no tutors relative to the number of learners. So for example, if you're taking a MOOC from, say, edX or Coursera, you might have thousands of learners signed on and maybe 10 or so TAs at most. So there's like kind of a 100-to-1 ratio, or even more. A lot of these learn-to-code sites are really popular now. So Codeacademy is where you can go through these coding tutorials and run code online. There's a system that I've been maintaining for the past few years called Python Tutor, which allows you to code into a web-based IDE and see what happens when the code executes to help yourself debug and understand execution. So in these sorts of massive online settings, there's usually a few TAs, or in these settings, there really aren't any tutors by default. It's very self-paced. But what if we were to be able to add tutors to these sort of online settings? What challenges do we face? So clearly, we can't rely on this ideal one-on-one tutoring. There just aren't enough people. So the main challenge with this work that kind of drives this work and some of my other related work is how can we make the most of a single tutor, right? The expert time is the most scarce thing in this online setting and even in person. So how can we make the most of them? So both in an in-person lab to help people in traditional residential settings, and also imagine the TAs in, say, a MOOC. And the approach I took was to build a real-time monitoring tool. So this is called Codeopticon, named after the panopticon here. So there's a tutor sitting on their computer, and they can simultaneously monitor up to dozens or maybe even 100 or so learners, all writing code independently on their own computers. And the tutor's in the middle here, conceptually just watching all the learners. So to show how this works, I'm going to show a simple case first of just one-on-one. So imagine you have one tutor here and one learner on their computer coding in, say, edX or Codeacademy or my Python tutor site. So the learner codes in any sort of web-based IDE they want. So my prototype is on my Python tutor site, but this could work on edX or Coursera. So I'm going to play this video. This video is going to play twice. The first time, you're just going to see the learner on the left side. So the learner is going to be writing some code and trying to debug it. And the second time, I'm going to replay the same trace. And the second time, I want you to focus on the right side, which is the tutor, what the tutor sees of the learner. So I'm going to play it once. So a learner is writing a function, product, 2 arguments, x, y. No, let's name it a, b. Okay, so how do we return the product? So return A times B, simple, right? We actually get a lot of things like this. This seems obvious, right? X is multiply. So yeah, clearly there's an error, but syntax error is not helpful, so let's try lowercase x. And there's still another error. Okay, so same replaying, now look on the right side. So what the tutor sees is this rectangular tile, and the learner's edits are being chunked up and replayed in real time. So the green shows additions, the flashing red shows deletions, so they're deleting, they're adding another few characters, return. And then when the learner tries to compile and invariably fails, the tutor sees that syntax error right there. And then they try again, they edit, and there's another error. So now the tutor can go use a history slider to go back and see all the learner's edits to kind of remember, how did they get there? How did they get to this particular error? Did they get this error before? And then now the tutor jumps in. They said, okay, I think you might be stuck. You tried this a few times. Open an inline chat. There's a pop-up that comes up, just like if you're using, say, a customer service site. And then they can both chat on this text-based channel and fix the error. So that's how it works in the one-person case. So to recap, each learner is summarized in a tile here. So there's language. This works on any language. It's agnostic. So this is an error here. Public is spelled wrong, so there's an error. And then the tutor can start a chat, and then the learner sees the chat in real time. So this is great for one-on-one, right? So this works beautifully if you are remotely tutoring your relative or friend or student remotely. But obviously we have more than one person. So what happens when you have a whole classroom or a whole MOOC full of learners? So the interface that this tutor sees is actually pretty simple. It's just a dashboard that's just a rectangular grid of these tiles. So this is the interface. This is 2 by 5 right now. On a laptop screen, you can fit 10 tiles like this. And each tile is just independently viewing one of the learners. It's just kind of like a window into their world. And the tile is purposely summarized so that you can fit a bunch of them on the screen. On a 30-inch monitor, you can usually fit 3 by 5. So in the user studies, we had a 30-inch monitor, you have a 3 by 5 grid. And this just all happens in real time. And I'll talk to you about the user study results in a bit. But basically, we're not expecting the tutor to be able to simultaneously watch all 10 or 15, right? It's like they direct their attention however they like. But they have this kind of situational awareness so they can kind of use their own judgment to see where to zoom in on. And this is in contrast to, say, if you're screen sharing or something, you can really only see one person at a time, right? And if you're trying to screen share with 5 people at once in 5 tabs, there's no way you can switch back and forth. So this is a way to really compactly represent over a dozen or 2 more learners at once. Okay, so this setup works pretty well as long as you have a fixed number of students. So let's say you have a 30-inch monitor, you have a 3 by 5, you have exactly 15 students in your class, in your lab, and they're all seated nicely in a nice 3 by 5 grid. You know who everybody is, and you sit back and you just do your thing. And it works perfectly, right? There's absolutely no fragmentation, no movement or whatever. So this static setting works really well. And I guess if you have one of these giant curve monitors, you can fit like 50 people on. And in a traditional class, this would be pretty good. Even this system is given, people are like, oh, I love to use this in my class. But again, we want to think about scaling. Let's think about scaling even more, right? So in an online setting, this is not going to be the case. We're not going to have, first of all, we're not going to have as few as 15 people. And second of all, the more important thing is that people are coming and leaving at really kind of unpredictable times. So here's some data I pulled from the Python tutor site. This is just 2 months of data. It's pretty representative. So this is the number of people arriving on the site per hour. So these are a number of new people basically entering the site and starting a code. The number leaving is about the same because the average people come and go. And it hovers around 200, 300 or so. Sometimes it spikes up to 1,000 per hour. What this means is a lot of people are just, they're taking a MOOC or they're learning by themselves, they're Googling for help, and they're starting to come in and just write some code, and then maybe they get distracted and they close the tab, or they pause for a bit and they go to surf Facebook. And it's not this case that they're just all sitting in a lab hour. Like, this is 3 to 4 p.m. We're all sitting in lab and coding together. Everyone just kind of going at their own pace. So how do we deal with that? The first way to deal with it is to just think about the numbers issue. So imagine a simple algorithm is let's just do first come, first serve. First person who joins, go here, 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 and we'll just stack up. And after 15, obviously you need overflow, right? You need more people down here. But the problem is that once you're down here, you really have lost the tutor's attention because scrolling is just way too high expense. Because already they're so fixated on looking at the 15 they see in front of them, they're just going to forget you if you're way down there. So that's not fair because just because you came a little later, you're penalized. Another problem is fragmentation. So, imagine this person is coding and then they leave. So, they kind of leave a blank hole right there. Should someone move up to the hole? What should happen here? Otherwise, you're going to have, not only are you going to pile down, with hundreds of people down below, you're going to have a bunch of gaps. So we need some way to reshuffle the tiles so that we kind of maintain some semblance of order. So I experimented various ways to do so. The way that ended up working pretty well balanced two goals, which are sometimes in conflict. So the first goal is to prioritize active learners. So the intuition here is that since online audiences are so heterogeneous and kind of scattered and transient, a lot of times someone goes to the site, they code for a little bit, and then maybe they switch a tab and they watch a video for 5 minutes and they're not doing anything. So not everybody is, if you actually see the user test, not everybody is frantically coding all the time. There's a lot of pausing, especially in an online setting. So we have to find some metric for this. So a simplest metric is just the number of events issued to the tool per second. So number of code edits, number of compile attempts, stepping through debugging. We do that per second to kind of get an activity level for each learner, and then we discount it to just do a simple exponential, because the idea is that the more recently you're doing stuff, the better, right? If you're doing stuff half an hour ago, no one probably cares. So that works reasonably well, and it's not a perfect metric because we can't really tell if, we can't tell intent just by you typing. But it works reasonably well. It filters down the idle people. So with this, you already get the idle people like falling down there. The second one is minimizing jitter. So if we were to just, all the time be swapping people, swapping and just sorting the list by activity, it would just be a total mess, and the tutor would not be able to keep track of anything with their spatial memory. So the way we deal with that is to just run a swapping every 10 seconds. So every 10 seconds, we want to swap pairs of people so that the more active people go on top. And in order to prevent jitter, we give a 5-second grace period. So if I was looking at this person and there's a green next to them, that means this person hasn't been active, we want to swap them out. If you just click on them, it'll just lock their tile and they won't be swapped. If you're chatting with them, the tile also locks, or you can just manually lock the tile. So that just prevents tiles from flying around that you don't really want to fly around. Okay, so the next 2 or 3 minutes or so, I'm going to wrap up by talking about the evaluation, the user study. So how well does this work? So I did a first use lab study. So this was an instructor in 7 TAs from the Intro CS course at Rochester, which was in Python. This is their first time ever seeing the tool, at all. So I basically gave them a short tutorial and said, spend 30 minutes helping learners on the Python tutor site, however way you feel like. There's no metrics, there's no scores or anything. Just use it in as natural a way as you would, like you were kind of tutoring in a lab. The learners knew, they opted in, they knew when they're on the site that your actions are being monitored for research and stuff, but they didn't know that someone was actually going to jump in to help them. And there's no way to actually call for help in this case because we didn't want to have that on the site because most of the time there weren't any tutors on there. So there would only be tutors during that half-hour block. So this total, we had about almost 2,000 people went through the site in all the sessions, and they came from 54 countries. So a lot of the low response rates were because they probably didn't speak English, and a lot of their code wasn't even in English. So this is a kind of a simulated worst case scenario, right? That in a real use case of this tool deploying, first of all, the tutors would be trained on it. You would know how to use this tool, and also the learners would know that they would be expecting it. It would be like, imagine you're taking a MOOC on edX or Coursera, and the TA says between 3 and 4 p.m. Eastern time tomorrow, I'm going to sign on this site and do live tutoring. So anyone who wants help, go on then, and I'll be there, and you can click a button and chat with me and stuff. So this is kind of the first pass scenario. Okay, so I'm going to sum up the results. There's a lot of graphs in the paper. The sum of the results is there's 2 sides. There's the tutor side and the learner side. So how did the tutors feel about this interaction? They did think aloud, and we interviewed them briefly afterwards. The most salient finding was that it was a really immersive experience. So on average, in every session, they tried to help 12 people. So they kind of looked around and tried to start chats with 12 people. They usually could handle about 3 chats at once. So usually people are not chatting with more than 3 people at once. And you can kind of multitask because sometimes you say try something and then they're idle for a while. And the cool part about the immersion is that pretty much everybody went over the time limit. Everybody after 30 minutes, they still kept going and had to kind of tear them away from the computer after 5 more minutes. Authenticity, so they really did get into it. They felt like they were tutoring in real life with their real personality showing. And even though there was absolutely nothing at stake, these weren't their students, nobody knew who they were, but they still had their ego kind of into it. They wanted to do a good job for themselves. Advantages? Big advantage, they said, was that you can control your own pace. So they said in a computer lab, since you're basically single tasking, you're being pulled in all directions at once, and it's hard to manage. History, so you can go back in time and just see how everyone's doing. And also you can privately Google for help. So they said that when they're tutoring in real life, they would sometimes feel ashamed if they didn't know the answer and they didn't want to admit they didn't know. But now they're just in private, so they can just Google all they want. Disadvantages? Obviously the text is really low bandwidth, right? This is not meant for a really rich, high-level interaction. Also, the tile reshuffling problem is that if a learner is actually stuck and sitting there, scratching their head, we don't really detect that because they're not actually doing anything on the computer. So you might imagine some better heuristics for that, but our simple one will penalize these truly stuck learners. Okay, so to wrap up, what did the learners learn on our side? So on average, around 2 to 3 learners confirmed that they got help successfully. So they said, thank you very much, I saw you solved my problem. Some of them actually just fixed their bug and solved their problem, but they didn't actually talk, confirm. The chat logs indicated both this kind of declarative knowledge, syntax, and also procedural knowledge, a tutor helping the learner debug. At the simplest, the lowest 2 levels of Bloom's taxonomy, which is remembering and understanding. So this roughly corresponds to remembering is roughly syntax, understanding is roughly semantics at a very basic level. And really this the upshot of the whole study and the interface is really this low bandwidth interface is really useful for the debugging and simple unstucking things, but it's not really for deep pedagogy, right? You're getting quantity over quality in this interaction. So to sum up, these are the things we observe and we wanted in face-to-face, and with Codeopticon we can get all of this and more. So we get this real-time dashboard enables the targeted, timely targeting proactive help. The user study scaled up to around 200-ish people. There's only about 50 online at once, but every session there are around 200 people coming in. The best quote here is Tutoring Podama. So they said, I would love to use this because I don't want to go out in the snow and I can just have my office hours in my room. So if you want more details, read the paper and I'll be happy to take questions at this time.
Hi, very nice talk. Joo-Ho Kim from Stanford and KAIST. I was wondering if you thought about ways to apply this system to other models of learning, like if you think about hundreds of people watching video at the same time, what would it mean for the video instructor to jump in and help them? Or maybe people who are having synchronous discussions using chat rooms and other things. So I was wondering about sort of the generalizability of this sort of approach.
Yeah, that's a good question about generalizability. The one obvious thing is anything related to writing or writing related, because you're writing code. So imagine if you have a creative writing class or even like a history class where you're writing essays and everyone's trying to structure an essay, or like writing a cover letter. Writing is the most obvious thing. Video I have to think a bit more about, but I would think about the writing part. Thanks.
Hi, Philip. Yeah, great talk. Josh Hipschman, Northwestern University. I'd actually like to use this back home. The question I have revolves around when I was an undergrad, I definitely programmed differently when I had a tutor or a professor looking over my shoulder. It gave me anxiety and I didn't do as well. How is that manifested in your tool? And without taking away anything from your tool, could this be addressed?
Yeah, that's a great question. I talked to the TAs about this, the user study subjects, and they said that they felt the students would like this better than if they were standing there physically, right? It feels a bit less intimidating, even if you know someone, because in this case, you're coding privately and someone may be watching, but they're not necessarily watching. Whereas in the lab, you kind of see someone hovering around. So, but we haven't really tested that, no.